9. Welcome to Chapter 1. So we're going to start today with 1.1, which is on square roots. So I have a question for you. Can you make a square with the following numbers? So here's what I mean. See these little squares in here? Here's a little square, here's a little square, here's a little square. What I want to know is, can you make a square that has 4 of these little squares in it? So for example, this has 4 squares in it, but that blue thing is not a square. Can you make a blue square that has 4 of these little ones in it? Yeah, you can do that, right? You go like this. There's a square, and it has 1, 2, 3, 4 little squares in it. Now, how big is each side? This side, the length is 2, and this side, the length is 2. All right, let's do it again. Next one's 16. If I was going to make a square with 16 little squares, how big would each side be? In this one, it was 2 by 2. How big would each side be if it was 16? Do you get it? It would be 4 by 4. And if I finish that up, I get a square with 16. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We've done it. And each side we said was 4 and 4. Okay, 36. Can we do that one? We can. How big would each side be in this one? It'd be 6 by 6, wouldn't it? 1, 2, 3, 4, 5, 6. Sorry, I don't have straight lines here. 3, 4, 5, 6, and up and across. It's not the greatest, but you get the idea. There are 36 of them in here, and it is 6 by 6. Okay, and the last one, 11. Could we do that? The answer is actually no. So this one, the answer for this one is yes, 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 but this one, no, we cannot do that. All right, now why am I showing you this? Okay, so it turns out that these 3 numbers, the first 3 are perfect squares. We're going to talk about that in a second. 11 is not a perfect square. And this also helps us introduce the idea of a square root. Okay, a square root is the opposite of squaring. Do you know what I mean by squaring? So squaring, for example, would be like if I showed you there was a square here that was 6 by 6, and I wanted to know how many little squares are inside. You could go 1, 2, 3, 4, but what would be a faster way to do it? You could just go 6 times 6, 6 times 6, which is 36, or you could do 6 squared, right? You've seen that before. 6 squared. We'll talk about this in more detail in a couple lessons, but hopefully you've seen this before. 6 squared is the same as 6 times 6. So again, if I showed you some square here, and I told you it was 8 by 8, how many little squares would have to be in it? Well, you would do 8 times 8, or you would do 8 squared. So square root is the opposite of squaring. When we square, we get the 64. 8 squared is 64. And when we square root, we get the side length, the 8. So this is square root, right? Looks like this. So with a square root, what you're looking for is a number that multiplies by itself to give the radicand. Radicand? What the heck are we talking about here? All right, we got to do some definitions here. This fancy blue thing here, not the 9, but the other thing, this is called a radical sign or symbol, the radical symbol. It's also called a radix, and it's also called a surd. But I think I'll go with radical sign. That's what most people call it, I would say, at least in our part of the world. Okay, so that's called the radical sign. And then the number inside here, in this case the 9, this is called the radicand. Okay, whether it's a 9 inside or a 17 or a 342, that's a radicand. Okay, and that's what I'm talking about here when I say radicand. So with a square root, what you're doing is you're looking for a number that multiplies by itself to give, in this case, 9. So you'd ask yourself, what's a number that multiplies by itself to give 9? Well, 3. 3 times 3 equals 9. So, in other words, the answer to this is 3. Okay, so let's go back here. I just want to show you that because these ones made the perfect squares, this 4 up here and the 16 and the 9, we could take the square root of all of these. Square root of 4, square root of 16, and the square root of 36. So again, what you're asking yourself is, what's a number that multiplies by itself to get 4? Well, 2 times 2 is 4, so the answer is 2. What's a number that remember, that's why we have 2 right there. What's a number that multiplies by itself to get 16? Well, 4 times 4 is 16. That's why we have the answer 4 there. What's a number that multiplies by itself to give 36? 6 times 6 is 36. That's why we have 6 here. What's a number that multiplies by itself to get 11? There is an answer, it's just not going to be a whole number. It's going to be 3 point something. We'll talk about that next day, so let's leave that for now. Okay, so today we'll be basically dealing a lot of perfect squares. And perfect squares are numbers that when you take the square root, you're going to get a rational answer. A rational number is a number that can be written as a fraction. Anyway, don't get too confused with rationals right now. We'll talk about that more later. All right, it might be helpful to make a list of the perfect squares. So here's the perfect squares. You should know these. 1 is the smallest perfect square, although some people argue that 0 is the smallest perfect square. Then 4, then 9, then 16. Where am I getting these numbers? Because 0 times 0 is 0. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. So that's a perfect square. 6 times 6 is 36. That's a perfect square. 7 times 7 is 49. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. These are all perfect squares. 11 times 11, 121. 12 times 12, 144. 13 times 13, 169. 14 times 14, 196, and 15 times 15, 225. Are there more? Yes. How many more? Infinite. So they go on and on and on, but knowing these 15 is very, very useful. So I can take the perfect square of any one of these, and I'm going to get a nice answer, right? Square root of 100. Yep, that is one of the perfect squares. It's right there. So I should be able to do this. What's a number that multiplies by itself to get 100? Not 50. A lot of people just cut it in half. That's not what this means. 50 times 50 is not 100, but 10 times 10 is 100. So the answer here is 10. I'm going to put here because if you're confused by this, the reason the answer is 10 is because 10 times 10 equals 100. Or if you want, 10 squared equals 100. Square root of 0, 0. How come? Because 0 times 0 is 0. Square root of 169. Yeah, it's on the list here, so it must be a nice whole number. Square root of 169 is 13. How come? Because 13 times 13 equals 169. These are the actual answers here. You don't have to put the because part. I'm only putting that in case you're having troubles understanding. Okay, these can look a little bit more difficult, but same idea really. So in this one, you have two numbers under a radical sign. You have to do the part under the radical sign first before you take the square root. So the first thing you're going to do is leave the square root and go 9 plus 16. Well, 9 plus 16 is 25. Now we're going to take the square root. Hey, we're in luck. 25 is on our list. It's right here. What's a number that multiplies by itself to get 25? 5 times 5 is 25. So that's our answer. Okay, this question looks almost exactly the same as the last one. You see the difference? This one, it has a radical sign here and a radical sign there. So you have to do them individually this time. In this one, we added 9 and 16, then took the square root. This one, you're going to take the square roots, then add. Okay, what's a number that multiplies by itself to get 9? 3 times 3 is 9, so our answer is 3 there. What's a number that multiplies by itself to get 16? 4 times 4 is 16, so the answer is 4. So now we're left with 3 plus 4. Oh, 3 plus 4 is 7, and that's our answer. Okay, a little bit more complicated, but I mean, same sort of thing. The first one is just the square root of 1. What's a number that multiplies by itself to give 1? 1 times 1 is 1. So the square root of 1 is 1. Plus, now don't take the square root of 1 here. This is all under the radical sign. So we have to add this. 1 plus 24 is 25. Now we can take the square root of 25. So I'm just going to rewrite the 1. Okay, square root of 25. A number we did that over here. It's 5. A number that multiplies by itself to give 25 is 5. So we're left with 1 plus 5, which is 6. Now, we're going to look at some different situations here. The first one is square roots of squared numbers. Sounds confusing, but what I mean is if you look at these three questions here, I have a squared bit right here. See, it's 5 squared and then square root. 8 squared and then square root. 35,721 squared and then square root. Ooh, that's going to be a tough one, isn't it? No, it's not. You'll see. If you get this, you'll see it's not hard. So when you first see these, what you'll probably do is you'll say, okay, the first thing I have to do is square this. So I'm going to keep the square root and 5 squared. That means 5 squared means 5 times 5, right? So I'm going to figure out what that is. 5 times 5 is 25. Okay, now I have to take the square root of 25. So that's a number that multiplies by itself to give 25. Well, wait a minute. A number that multiplies by itself to give 25 is 5. So our answer is 5. Huh, that was weird. We started at 5, multiplied by itself, and then came back down to 5. Do you see what's happening here? We have a squared, which is highlighted there, and I also have a square root. And those two things are opposites of each other. So they're going to undo each other. It's kind of like if I take any number, like let's say 17, and I add 3, and then I subtract 3. Where do I end up at? 17. How come? Because these two things undo each other. Same with our squared, that 2, and this square root, they undo each other, and so because they undo each other, the only thing that's left is 5. Okay, I'll show you another one. We'll do it long ways, and then you should be able to do the rest super fast in this type. So the first thing you might want to do, but you'll soon see this is a waste of time, is you could do 8 squared. Well, 8 squared means 8 times 8, and 8 times 8 is 64. So now I have to take the square root of 64. What's a number that multiplies by itself to give 64? 8 times 8 is 64, so my answer is 8. But wait a minute, we didn't have to do all this work, did we? You should have been able to see right away, since you're squaring something and square root, they just cancel each other out, and you're left with 8. So please, can you tell me what the answer is to this one? You should be able to tell me the answer right now. Don't do any of this nonsense of don't do this, don't do this. Just give me the answer. Because this squared and this square root sign undo each other. They cancel each other out. So those are both gone. And look, your answer is staring you in the face. The answer is 35,721. Okay, so watch out for that. Next one, square root of fractions. Ooh, this looks hard, doesn't it? All right, I'm going to write down a couple steps for you. I'm going to start with step 2. Step 2, I know it's weird. I'll give you step 1 in a second. Step 2 is take the square root of the numerator. You know what the numerator is? It's the top number in the fraction. And the square root of the denominator, the bottom number in the fraction. That's it. That's all you do. So we're going to start. We'll do this one here. We're going to take the square root of the top number, the numerator. What's the square root of 4? What number multiplies by itself to get 4? 2. 2 times 2 is 4. Okay? Now we take the square root of the bottom number, the denominator. What number multiplies by itself to give 9? 3. 3 times 3 is 9. There's your answer. By the way, another way maybe I should have written this. This is the same as the square root of 4 divided by the square root of 9. Right? If you have one giant radical sign, you can split it into the top, the numerator, and the denominator, and we get our 2 over 3. Now, this one doesn't look very promising. Square root of 2, a number that multiplies by itself to get 2, and 50, a number that multiplies by itself to get 50. Let's go back and look at our list, and I think you'll see with our perfect squares, there is no 2 on the list, and there's no 50 on the list. So does this mean this question is not possible? That does not mean that. You know why? You know what you could do with this fraction? You could put it in lowest terms. So that's what you should be doing first. Before you give up and decide you can't do it, put it in lowest terms. You know what I mean by that? I mean, what goes into 2, or what can you divide 2 by, and you can also divide 50 by the same thing. You could divide them both by 2, couldn't you? You could divide them both by 2. And if you divide them both by 2, you'll end up with 2 divided by 2 is 1, and 50 divided by 2 is 25. Hey, 1 and 25, I think this is good. I believe those are both on our list. There's 1 underlined already and 25 underlined already. Great, we're going to be able to do this. So remember, if you want, you don't need to show this step, but what we have written here is the same as the square root of 1 divided by the square root of 25. You take the square root of the top, you take the square root of the bottom. So what's the square root of 1? What number multiplies by itself to give 1? 1. What number multiplies by itself to give 25? 5. 5 times 5 is 25. So that's your answer. Okay, this one. Ooh, this one looks horrible. It's in lowest terms, but how on earth do I do this? All right, this time you better put it into improper form. I also call that top-heavy form. Remember how to do that? This is a great grade 8 skill that hopefully you remember how to do. You multiply the whole number by the denominator, so that's 11 times 9, which is 99, and you add 1. 99 plus 1 is 100, and then you keep the denominator the same. Okay, so this is actually what we're trying to find the square root of. What's the square root of 100? What multiplies by itself to give 100? 10. What's the square root of 9? What multiplies by itself to give 9? 3. You're done. Okay, square roots of negatives. Okay, if the negative's out front here, it's not a big deal. All it means is your answer is going to be negative. So you're going to take the square root of 81. So what number multiplies by itself to give 81? 9. 9 times 9 is 81. And it's negative. So put a negative on it, you're finished. No problem, right? But this one's a little different. This one, the negative's inside the radical sign. So what you'd be looking for is a number that multiplies by itself. It has to be the same number, and you get negative 64. All right, now, what a lot of people think when they see this question is, well, I know that the square root of 64 is 8, because 8 times 8 is 64. So the answer must be negative 8. What do you think? Is this right? Well, let's try it. If you're not sure, let's try it. Let's put negative 8 in here, and let's see if it works. Does negative 8 times negative 8 equal negative 64? No, it doesn't. How come? Because a negative times a negative equals a positive. So that did not work. So no, at this point what a lot of people say is, well, I guess it's not negative 8. I guess the answer is actually positive 8. So let's see. 8 times 8 is negative 64. No. 8 times 8 is positive 64. So this didn't work either. So in this case, what people do is they say, well, it must be this, must be the answer. Okay, great, except for one thing. I mean, this is true that negative 8 times 8 is negative 64, but we need to have the exact same number in this purple line and this purple line. We need to have the same number. We can't do it. You cannot take the square root of a negative number. It's impossible. So I'll write that down for you. You cannot take the square root of a negative number. And what you would put for that answer is not possible, or you could put this. It means the empty set. Don't just put 0. That's not the correct answer. This means there's no answer, basically. Okay, I'll circle it. That's no answer. Okay, this one here, is this a problem one or an okay one? This is fine. It looks complicated because it's a fraction, but we just did fractions. You know how to deal with that. And this negative's outside, so we're in good shape here. All this means is we have a negative, and then remember, if you have a fraction and a radical sign, it means take the square root of the top and take the square root of the bottom. And our answer is going to be negative. So I'll put the negative right now. What's the square root of 1? What number multiplies by itself to give 1? 1. What number multiplies by itself to give 121? 11. So there's our answer right there. Okay, now, if you're a deep thinker here, you might have noticed something that's a little strange. I told you, for example, that the square root of 16 is 4, and the reason for that is because 4 times 4 is 16, right? So sometimes deep think people will say, wait a minute, couldn't the square root of 16 also be negative 4? Because negative 4 times negative 4 also equals 16. Is this true? It is kind of true. I mean, everything here is kind of right. So this is totally true, and this one's kind of a question mark. So we have something called the principal square root. And what the principal square root is the positive number square root. So this answer here, this positive 4, this is the principal square root. This negative 4 is not the principal square root. And by convention, just by kind of like agreement, it's agreed that if you're asking for the square root of something, you only give the positive answer. You only give the positive one. So there'll never be a case where they ask you for the square root of anything, I don't know, like 25, and you'll never put negative 5. That's never the case. When you're asked for the square root of a number, you just give the positive answer, don't give the negative answer. Okay everyone, this video has gone on long enough. We'll do cube roots and higher order roots next time. So that's it for today. That was a lot. If you have any questions, of course, let me know. And good luck to you. See you later.